Hi guys, so today we're continuing Unit 5 and today we're going to talk about triangle inequalities. So the first thing we're going to talk about is the actual triangle inequality theorem. So what is it? What do we need it for? So the triangle inequalities theorem states that you can only have a triangle, or a triangle is only going to exist if the sum, okay, that means you add them, of the two smaller sides is larger than the third side. So we have three numbers. We have to identify your C value, because that's the only one we're really worried about, because the other two are going to be smaller and we're going to add them. So it doesn't matter the order we add them in, as long as we add the two smaller sides. And so symbolically, this is kind of what it looks like. So it says if you have three numbers, right? And so this is saying that number is smaller than that number, and that, which is telling me that C is my largest number. And so if I add the two smaller ones and they are bigger than my largest value, then I can say then triangle. Then I can say then triangle ABC exists, right? And so here are some examples. So between these three numbers, identify my C, or my largest side. Not necessarily C, but my largest side. And so then that means that I'm adding the others too. So 8 plus 17. And then I'm going to compare that to 24, right? So 8 plus 17 is 25. 25 is greater than 24. So that satisfies the requirements for it to be a triangle. So in this case, yes, these sides are represent a triangle. And so let's do the same thing here. So between these three numbers, that's my largest one. And so I'm going to add the two smaller ones, and I'm going to compare it to that third side. And so when I add these two are smaller than 7, right? And so in this particular case, because the two smaller ones was equal to 5, which is not greater than 7, then in this case we can say no, they do not represent a triangle. Same thing here. So 50 seems to be my largest side. So I'm trying to see, are the two smaller sides, when I add them together, greater than 50? Right, so that's what I'm checking for. So when I add them together, I get 50. But even though they're equal, they're both 50, it does not say I want it greater than or equal to. I want it specifically greater than. So in this case, no, it's not a triangle. Okay, it doesn't represent a triangle. So what are the possibilities? So let's say that we're given two sides of a triangle and they're asking us to find that third side, or the possible measurement of that third side. Well, there's a couple possibilities, right? So let's just say our third number here is going to be x, right? So there's two scenarios. One where, let's say 22 is my largest side. So if 22 is the largest side, that means that 14 plus x, in order for it to be a triangle, have to be greater than 22, right? And so if I were to solve for x here, I simply subtract 14 and I get my first answer in my first scenario of x being 8. But what if 22 is not the largest side, and what if x is the largest side? Well, then we have our second scenario, and that is, well, if x is the largest side, that means that 14 plus 22 both have to, when you add them together, have to be greater than x. So in other words, I'm solving for x here, and so when I solve for x, I simply add 14 and 22, and I get 36. And so here I have my two possible solutions for x, right? So I can write this pretty, and I can say the range for x, or the two possible values, or the two possible measurements for that third side, is the x has to be greater than 8, but it cannot be greater than 36. So in other words, my range here would be x has to be between 8 and 36 in order for me to be able to create a triangle. And so same thing here, right? So if x is my third side, okay, the first possibility is, what if 31 is my larger side? Well, if 31 is my larger side, that means that whatever 28 plus x, it has to be greater than the larger side of 31. And since I solve for x here, I simply subtract 28 from both sides, and I get x to be greater than 3. The second scenario is, well, what if x is instead my larger side? Well, if x is my larger side, that means that 31 plus 28 have to be greater than x. And so if I solve for x that way, I simply add these two, and I get 59. And so here are my two possibilities, or here's my range for x. X has to be greater than 3, but less than 59, right? And so if we kind of follow this pattern here, the pattern turns out to be that to get my lower value, right, I simply take the difference between the two values that it's giving me, the two sides, right? So to get this bottom value, or this bottom range, we take the difference. And to get this upper value, or this upper range, we add those two, or we take the sum of them, right? So we say they take the sum. And so really is the same thing every single time, right? So the difference between these two, okay, so difference between, now we have to be a little bit careful, right? Because we don't want to end up with negative numbers. And so when we do the difference, we're going to subtract the smaller number from the bigger number. So in this case, we're going to subtract 3 minus 11, right? So if we subtract 3 minus 11, then we are going to end up with my lower value to be 8. And then if I do the sum, if I add them together, I get 14. Okay. So then there's another extension of the theorem. And so it's how we can classify triangles by their sides according to their size, right? So if we want to classify something as a right triangle, the converse of the Pythagorean theorem is a squared plus b squared equals c squared, right? So the important part here is that c, right, c is your biggest slash longest side. Okay. And so let's try some of these out, right? So if we're going to classify something as a right triangle, okay, first identify your C, and then your A and your B don't really matter because we're adding them. So the only one that matters here is C. So C is 5. So we're trying to see, we're basically comparing them. So we squared A, we squared B, and then we're trying to see how is that compared to C squared, right? So if it's equal to, then it's going to be a right triangle. If they are less than, then it's going to be an obtuse triangle. And if it's greater than, then it's going to be an acute triangle. And so 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 plus 16 is 25, and that's equal to 25. So because these are equal, then we say that these sides represent a right triangle. And so we approach it the same way. So now we're we try to figure out which between these three sides, which one represents C, which one represents the longest or the biggest side. Now between 2 and 3, we can easily compare that. 3 is a little bit bigger than 2. But if we're looking at the square root here, a little number sense, right? So if we don't have a calculator in handy, we have to figure out, well, what number is that, right? So little number sense. So we have to figure out, how does that fit in here? Is it smaller? Is it bigger? Is it in the middle? So that's what we're trying to find. So a little number sense. So the square root of 3. Okay, so that's a little bit hard, but so the square root of 4 is equal to 2, right? And which is telling me that that number, since it's smaller than the square root of 4, then therefore that whatever that number is going to be less than 2, right? And so if that's less than 2, that's telling me that that's definitely smaller than 2 and 100% smaller than 3. So that's telling me that 3 is going to be my C. And so we have the square root of 3, that's going to represent my A, and I'm going to square that, plus B squared, and I'm trying to figure out, how does that compare to my C squared? And so the square root and the squared cancel, and I'm left with 3. The 2 squared is 4. Trying to figure out how does that's going to compare to my 9. So 3 plus 4 is 7, and since 7 is since 7 is less than 9, then we can confirm that indeed it is an obtuse triangle. Which brings us to our last type of triangle and how we identify them. So once again, we know 4, right? But now we're dealing with these square roots that we don't really have in number 4, right? So once again, a little number sense, right? So here's the square root of 7, okay? Something below it, so that we know for sure is the square root of 4. The square root of 4 gives me a value of 2, right? The square root of 7 is definitely greater than 4, okay? And then something above it is the square root of 9, and the square root of 9 is definitely 3. So we don't really care about the actual value of square root of 7. We just want to know, how does it compare to the other numbers, right? And so the square root of 7 is somewhere between 2 and 3, okay? Now we got to figure out, well, since it's between 2 and 3, it's definitely smaller than 4, right? So far, 4 is my bigger number. Now we got to see, where does the square root of 11 compare, right? So we're going to do the same thing. So square root of 11, where does that fall relative to the other two numbers that I know for sure? So the smaller one that I know is square root of 9, and the next bigger one that I know is the square root of 16. Well, the square root of 9 we said was 3, the square root of 16 we said was 4. So therefore, the square root of 11 falls somewhere between 3 and 4. So since it's less than 4, that's telling me that 4 is my C value. That's my biggest side, my longest side. And so since that's my longest side, that means that that's A and that's B. And so when I square them, so we have root 7 squared plus root 11 squared, and I'm trying to see, how does that compare to my C squared? And so the square root and the square cancel out. I'm left with 7. Square root and 2 cancel out. I'm left with 11. How does that compare to my 16? 7 plus 11 is 18, and 18 is greater than 16. So in this case, we indeed have an acute triangle. So in the chat, there is a poll. I want you to pause the video, find your answer, and then tell me which one of these it is. So I hope you actually paused the video. So between 4 and 5, or 5 and 4, we know 5 is bigger. So we just got to figure out, where does this fall in, right? So the same thing we did earlier. So the root 35, and we're trying to figure out something above it, something below it. So something above it is the square root of 36, which is 6, right? Something below it would be the square root of 5. Sorry, not 5, 25. And the square root of 25 is 5. And so that's telling me that the square root of 35 falls somewhere between 5 and 6. Well, if it's somewhere between 5 and 6, that means it's bigger than 5, which means that this is my largest side, or that's my C. And so if that's my C, that's telling me that that's A and that's B. And so that's what I'm going to compare it to. So A squared plus B squared, and I'm going to try to figure out how does that compare to my root 35 squared. So 5 squared is 25, 4 squared is 16. Trying to figure out what goes there. The square root and the square cancel, and then 25 plus 16 is 41 is 41, and that is greater than my my C value. So since that's greater than my C value, that's telling me that I'm going to have an acute triangle. All right, so there's another thing. So it feels like common sense, but we're going to go ahead and make it concrete. So it says if we're trying to order angles or sides, right? So understand that, you know, the relative size of each side is going to be relative to the angle, right? So what I mean by that is if you have a small side, then you're going to have a small angle, right? So they go across from each other. And so it's asking us to arrange these angles, right, from least to greatest. And so in order for me to do that, I'm going to look at the sides, right? And so looking at the sides, I'm comparing them. Which one is the smallest side? So the smallest side would be 7. And so the smallest side is going to be across the smallest angle. So here, my smallest angle, or my least measurement of the angle, would be angle A. And then the one in the middle is 10. And so that would be angle C. And the largest side is going to go across the largest angle, which in this case is angle B. And the same thing for the sides and the angles, right? So the biggest side is going to go across our greatest angle. The smallest side is going to go across the smallest angle. Now, here we have the two angles, but we're missing the third. But remember, when we add up all the angles inside a triangle, they should always add up to 180 degrees. So if we do 180 minus 145, and the 145 came from adding these two angles together, then we get 35, right? And so sorry, and so 35 is the measurement of this third angle here. And so now I compare all three angles. So here's my smallest angle, which means that's going to be my smallest side. So we can say side ED, and then here is the one in the middle. So we can say side DF, and then the largest side is going to be here, so it's going to be EF.